So we have our equation for our exponential function, y equals b to the x, which has an inverse. Write that in the blank. Function found by writing x equals b to the y. And like I said, to find an inverse function, you just switch the place of the x and y. And then you solve. So the thing is, to solve this equation, we don't really have a method. So that's why the logarithmic function is introduced, is to get this y out of the exponent. So we can solve this by taking the log of both sides, and it turns out it'll look like this once it's solved. Y equals log base b of x. So these two equations are both talking about logs. They're really the same thing, just written in two different ways. Okay? And you saw in the video one way that you could think about saying this, and I'm going to share with you the way that I like to say it to help me remember what it means. I say, do you remember learning how to translate from math into English, maybe in Algebra 1? And the addition symbol, when you're reading a word problem, right, and you're trying to figure out, well, how do I translate this into an equation that I can solve? And if you see the word and, it means plus. If you see the word is, it means equals. Those kinds of things. So in the same way, we're going to translate this expression into English. Y, and then the equals symbol is, the word is, log will be translated into the power you raise, and then b to, I don't feel like this is necessarily grammatically correct, but it helps us think about how to go from one to the other. The power you raise b to get x. Y is the power you raise b to get x. So if you just think about this symbol, log, translating into the power you raise, it'll make things go a lot easier. So let's take a look at our graph. We're going to graph these two equations. We're going to graph our exponential function on the same graph as our logarithmic function, so we can see what those inverses look like together. So on the left side, we're going to make our t-chart. You can get out your 7.1 notes. So we have this t-chart already filled in for the most part. So x goes on the left, and then we're going to do y equals 2 to the x was the equation we used for an exponential function. And we're actually going to plug in values of -4, -2, 0, 2, and 4. And we went through the whole process of simplifying when we did the 7.1 notes, but today I'd just like you to get out your graphing calculator and type in your graphing calculator 2 raised to the -4th power. You'll get a decimal answer. -4th, since x is -4. Good, 0.0625. So at -4, this is a graph going up by intervals of 2, so -1 is right about there. So -0.0625 is really close to the x-axis. I'm going to put my point down there. Next, if you type in 2 to the -2nd power, maybe you already remember, that means 1 over 2 to the 2nd, which is 1/4 or 0.25. So at -2, we're only slightly up here, 0.25. Raising anything to the 0 power gives us 1. So at 0, we're at 1. There's not actually a line for 1, so you kind of have to just look for halfway between the 0 and the 2. 2 to the second power, 4, right? So 2, 4. And then 2 to the fourth power, 16, which happens to be off the chart, so somewhere up there. So we're just going to draw the curve, connect the dots, draw the curve. Somewhere up here. And let's just label that y equals 2 to the x. On the right-hand side, we will make a t-chart. And we're going to do x equals 2 to the y power. So this is our logarithmic function. Right? There's 2 ways to write it. And then we're going to put our y values in on the right-hand side. Rarely do you enter y values and then solve for x. Okay? When we're dealing with inverses, though, that's when it tends to happen. So we're going to plug in values for y. -4, -2, 0, 2, and 4. You're going to see a pattern here pretty quickly. When we plug -4 in for y, we have 2 to the -4th. We just calculated that, right? What was it? 0.0625. Good. We raise 2 to the -2nd power. We get 0.25. 2 to the 0 power. We get 1. 2 squared. 4. And 2 to the 4th, 16. So it is the same t-chart, only switched. The x's and y's are switched. Same thing as what we did with the equations themselves. We switched the x and y values. So then I graph at 0.65, which is just really close to the origin there. We get -4. 0.25, we get -2. At 1, we land right on the x-axis. At 4, we land on 2. And then at 16, which is off the charts on the x-axis this time, we would land at 4. So we're going to connect these dots. Label this equation x equals 2 to the y. That's an exponent. The y is in the exponents. When I draw it's hard to make the y without dragging it down. Pretend like the y is just up here. And now if I draw a dashed line representing y equals x, you can see that the graphs are just the reflection over the line y equals x, which is what we tend to get when we're talking about inverse functions, just the reflection. Again, the first equation graphed was the exponential function. The second was the logarithmic function. So if it asks what does the exponential function look like, it's just this one. If it asks what does the logarithmic function look like, the parent function, it looks just like this one. Okay, they only come together when we're talking about them in this situation. Now we have another application of logarithms when we're talking about Google PageRank. So can someone volunteer to read measurement scale Google PageRank? Thanks, Maddie. It's at the bottom right here.
Google gives every page on the web a score, PageRank, which is a rough measure of authority or importance. This is a logarithmic scale, which in the head means PageRank counts the number of digits per score.
Good. Flip it over.
So a site with PageRank 2 digits is 10 times more popular than a PageRank 1 site. My site
pause. Thanks. So since their rank is 9, they are 4 digits, they get 4 more digits of views per day, so that's why you see the 4 zeros here, which the 7,000 was the rank of 4. So you can see where the 70 million comes from. All right, so you can see why they're using a rank system that is connected to logarithms versus saying, oh, you're a rank of 70 million. It starts to kind of not, we don't relate as well to talking about a rank of 70 million versus a rank of 7. Oh, you're a rank of 9. Okay, so, but there's a huge difference in the number of times that those websites get visited, right, per day. So moving on. That is just a situation where logarithms are used in the real world. There are several others if you're interested, if you're the kind of person that's like, but when is this ever relevant in the real world? Take a look at that website. It's pretty cool. We have 3 examples, so 3 different ways to go back and forth between the 2 different ways to write the equation and solve logarithms. First skill is to be able to go from an exponential equation into a logarithmic form. Number 1. 2 is the power you raise 10 to. So this should sound familiar from the front. 2 is the power you raise 10 to get 100. We'll write that down. 2 is the power you raise 10 to get 100. Oh, sorry. Yeah, good. No, B, 4. So starting with the exponent, right? This is our starting point. 4 is the power you raise. The base is 3, so the power you raise 3 to get 81. I'm not going to write it out each time. I think one example on this side is helpful. And try to letter C on your own. Try converting from your exponential form to your logarithmic form. So 2 is the power you raise 7 to get 49. Raise your hand if you got this. Nice. All right. Skill number 1. Check. Skill number 2. Evaluate each logarithm. So what does this equal? It helps if we put an x. So let's write equals x. Just as we begin to think about how to answer these. So it helps me to think, okay, x is the power you raise 2 to. So 2 to what power is 8? And this is where he counted on his fingers, and you may not be able to count in terms of 2's to a power. So 2 to the first power is 2, 2 squared is 4, 2 cubed is 8. So 2 to the third power is 8. So x equals 8. Or no, sorry. X equals 3. 2 to the third power is 8. Here, again, we're looking for the power that we would raise 7 to get 49. And it's absolutely fine to write equals x and put the x as your exponent, because we're just more used to seeing it this way and thinking about, okay, 7 raised to what power is 49? So we go 7 squared is 49. That's 2. And then, so 9 to some power equals 81. So 9 to what power is 81? Yep, 2 again. Okay, and that's called evaluating logarithms. So skill number 2, check. Skill number 3, solve for x. So here, again, we're going to write it in its exponential form to help us think about it. So 2 is the power you raise 3 to get x. Or 3 squared is 9. Four is the power you raise 5 to get x. So 5 to the 4th power is x. Again, no shame in just getting out your calculator and typing in 5 to the 4th power. Good. And then try C on your own. Anybody get the answer for that one? Tisha?
60466 plus 76.
Did you get 10 to the 6th equals x? Or did you use 6 to the 10th?
6 to the 10th.
Easy mistake to make. So make sure that the number that it's equal to becomes the power of the base.
Okay.
So 10 to the 6th, so x would equal, I heard it over here, 1 million, good. So there are 6 zeros on there. And that is your notes on logarithms.